Hello everyone, welcome to techfix.com. So our today's project is a solar grid monitoring system using Internet of Things. So this project is basically it can be used to monitor the impact of solar power generation on the electrical grid like grid stability, voltage stability and power quality. So, in this project, the solar energy that will be taken in by these three solar panels will be utilized by this control panel for supplying power to this source. Here is an LED. You can store the solar energy into some battery or any other application that you want to. So, being an IoT based project, this project represent these values of temperature, light and solar energy generated over the internet. And here we have measured these values using these sensors. The one on the left is a temperature sensor and on the right is the LDR, that is light dependent resistor. So the temperature and intensity of light are two of the most important factors that need to be monitored here. And the third factor that we have got access to here is the power generated by these solar panels. And for testing this, we have a source here. So here, as soon as I restart this system, you can see that it displays IoT based solar grid monitoring system and shows the status of power as on. So this simply means whether the power generated by the solar panel needs to be supplied to the load or not. We can also block it, but for now we have to keep the power supply on. As you can see, let me restart it again. You must have seen the power status as on in the LCD. Here it is power status on. So instead of this LED, you can use any other load as per your convenience. Other than the solar power generation, here we have temperature and light measurements. So these two values have been measured using the two sensors as I had shown earlier in the video. The temperature sensor on the left side that I have used is LM35, and the LDR that I have used here is a normal photoresistor that can be available at any electronics material shop. So next comes the role of Internet of Things. As I told earlier, the values are also being displayed over the internet. So for monitoring these values remotely from any corner of the world, here we have an application interface as shown on the screen and in the mobile shown in the video as well. So as you can see that the same values that we are being shown with on the LCD are being shown on this application interface as well. The values of temperature, light and voltage from the solar cell. We can also control the power socket from here, as I had told you that we can control the power supply towards our load. The microcontroller that we have used here is ESP32 to display these values over the internet since it has an inbuilt Wi-Fi module. So here you can see that as soon as I press the off button, the power generated by the solar panels will not be provided to our load further, and even on the LCD it displays the power status as off. I'll demonstrate this status again, and as soon as I press the on button, it updates the status on the LCD as well, and the power will be supplied to the LED or any load attached to the system. So in this way you can monitor the solar power generation, light intensity and temperature at this LCD and remotely at some other location as well. In addition to that, you can also control whether the generated power has to be supplied towards your load or not. This too you can do remotely, as the application interface consists of a button that allows you to control that power supply. Here, as soon as I press the off button, the power supply towards the load would be stopped. Now let's create a different atmosphere for our project. Now we'll try to change the parameters that it has been measuring. So here I have covered the light sensor with my hand, and you can see that the light value, the percentage of light intensity that was being shown in the LCD has decreased to 0% since no light is reaching our LDR. can be seen on the application interface as well. And now I have covered the temperature sensor with my hand, since our body temperature increases the temperature, and here you can see that the temperature value on the LCD is also increasing. It has reached 26.5 degrees Celsius. Now you can see that as soon as I removed my hand from the sensors, the values of temperature and light intensity have got back to the previous normal values. In the same manner, when we will cover the solar grid with our hand, then we will notice that the voltage from the solar cell is being affected. Here I have covered it with my hand, and here you can see that the voltage generated by the solar cell has decreased. It has decreased significantly. So this is how this project works, and here it should be noticed that the light source that we have taken here is this, and if you will place this project in the solar light in the outside atmosphere, it would give even better results. So this way you can remotely come to know about the status of weather on some particular day and the status of the voltage generated by the solar cell remotely using the application interface, since the same values at the LCD are being shown on the application interface as well. So in this manner we have covered the aspects of telemetry in this project. Telemetry means remotely monitoring certain data, and other than that we have also covered the aspect of tele-remote controlling, as we can remotely control the power supply towards our load using the application interface. So that's all. I hope you all like this project. If you want to buy it or have any queries regarding it, you may contact on the number given here, and you can also go on the link given in the description below. Don't forget to like the video and subscribe our channel. Thanks for watching the video and have a good day.